Welcome back, everyone. In this video, I am going to try my very best to explain what decorators are in Python by using various examples. Now, this does rely on another concept, which is called first-class functions, which I have a video coming up after this about it. You might say, well, why don't you do that first and then do this one? I find throughout my teaching that when people see something first, then learn about it, about the concept behind it, or if you will, the theory behind it, it seems to work better. I'm not quite sure why our educational system insists on teaching the theory and concept first, then the practice, because we seem to learn the other way around. But in a nutshell, a decorator is a function that has that modifies the behavior of another function. Now, this is based on this concept of first-class functions or higher-order functions, which you already know about, whether you knew it or not. But just to illustrate the idea, let me just insert a cell right above here, just to remind you of your algebra concepts. You may recall you had this thing called, for instance, f of x, and this was equal to, say, x plus, say, 7. You probably remember that very well. And at some point, you were told that you can have y be equal to f of x. And you had no problem with that. So here we have a function with a definition, and here we have a variable where a function is assigned to a variable. Later on, you learn that you can have g of, for instance, x is equal to x minus 10. And you could also combine these things. You could say, well, I want to have y is equal to f of g of x, which was considered composition. This is what higher order functions are in a nutshell. In other words, you can have a function be treated like it's a variable. It can be assigned to variables. It can be passed as variables. It could be made part of another function as a composition. String a bunch of these together, and that's what first class functions are. And in any language that supports that, which basically is all of them, they are referred to as first class function languages, or these are first class function concepts. Okay, they can certainly be passed, as you can see, as parameters. So hopefully this clarifies something that you've known since you were probably in middle school or high school when you first learned about this stuff. That being the case, let's take a look at a simple example first. I have a function here called outer function, which, as you can see, just has a variable called message, which says hi there. It doesn't do anything with it. Then there's a function defined inside of this function, which is called inner function, which prints this message and then returns inner function. Now, I want you to see that this return statement is for the outer function. So it's not inside. It's not here, which would make it part of the inner function. It's inside, lined up for the outer function. So when I return the inner function, this is going to execute the function and return the results, because let's take a look at it first. It says hi there. I want to point out that when I'm returning inner function with these parentheses, I'm actually executing the function. These parentheses execute the function. So if I come down here where I have the same construct, identical, except it's missing the parentheses. I'm still saying outer function with parentheses. And notice it returns the function object. It doesn't execute it and return the results. It returns the function. So it goes back to the same idea of these functions being first order functions. Very important concept here. Of course, I could just say outer function without the parentheses and I'd get the same results. So the parentheses execute the function. And this is, if you've ever seen this, say, in JavaScript or any other language, where you're wondering why sometimes the parentheses are included, sometimes they're not included. It's a matter of if you want to return the function itself, so you don't include the parentheses, or you want to execute the function and then return the results. So you include the parentheses. So it executes it, and then the results are assigned, let's say, to a variable or the passed along as a parameter. So please keep that in mind. Hopefully that makes it clear. So a decorator is just a function that takes another function as an argument, adds some functionality, and then returns another function. Let's go down here and take a look at the myfunc, which is a variable, just like I had up here saying y equals f of x. I can say myfunc is equal to outer function. And if I do that, it executes it, of course. I can say myfunc with nothing, or I can say myfunc with the parentheses. In this case, notice that I got this error message. If I come back up here and execute this one more time, I apologize. Let me do this, and then do myfunc. I can see that the function is returned as expected, and then with the parentheses, of course, it returns the results. I could go ahead and call outer function, as you recall, in this case, and it returns, because I ran this one as the last one, that returned the function, so this returns the function. I can add an extra set of parentheses to execute what was returned, which was a function, so execute the function that was returned, and there we go. Okay, so the parentheses execute the function, and this is referred to as closure, in case you're wondering. So now that hopefully this is clear, let's take a look at removing this message variable that I have, and just pass a message to this outer function. So I still have the same construct, the outer function, the inner function. I'm passing a message. You know what, let me make this be message so it's a little bit clear. So I'm going to pass the message to this outer function, and then the inner function is going to have access to that message. It can print it, and then I'm returning this function. Notice I am not executing the function. So what I can do, I can have variables. You can think of this as y equals something, x, or z equals something. I can have a function called t function and something called coffee function to make it more interesting. And I'm going to say coffee time and tea time here. So tea time and coffee time, let's say, just because that's what I like. So if I execute this, these variables are assigned these functions with the messages passed. Now, what happens if I just call tfunc here, and notice that the parentheses are there, so it's going to execute this. I get tea time, and if I call coffee func, I get coffee time. Now, keep in mind, if I were to do this, it simply just returns the function, because that's all that's being returned, is the function is being returned to this. So tfunc itself is the function. To execute it, I need to put those parentheses, and that's what's referred to as closures. Keep that in mind. So now let's take a look at what a decorator is, because we have actually been working with them and we just didn't realize. So what a decorator is, you have an outer function which takes potentially some parameters. There is an inner function, which we typically call a wrapper function, which can do something, and then we return this inner function, this wrapper function, ready to be executed. So that being the case, let's go ahead and execute this. You can see the only difference between this and this is just changing the names. I haven't really done anything other than that. So the functionally, they're the same. So if I take this decorator function and pass to it the message of coffee time, well, this returns a function, a wrapper function. This wrapper function needs to be executed. Remember, the wrapper function simply prints a message. I put a note here, so all I have to do is add these parentheses here, and there you go. The function, the wrapper function was executed, this message inside. So let's, instead of printing a message, pass in a function. So up until now, this message has been, a text that we're passing. But why not we actually pass a function? So we pass in a function, execute the function. This makes this construct at this point officially a decorator. So I have a decorator function where I'm passing in an original function. Then I have my wrapper function where I return this original function that was passed, but notice that I'm executing it. I'm returning the executed, or the results of that function being executed. And then I return the wrapper function, which basically returns this original function being executed. Let's go ahead and create this, and then I have a function called display, which simply says display function ran. Let's take a look at it. And what does display do? It says display function ran. Okay, wonderful. I can have a decorator display is equal to call this decorator function and pass to it the function display. Okay, remember display is a function right here. If I do this and then take a look at decorated display here, notice it says display function ran. So what's going on right here is I'm calling this decorated display is getting the value of the decorator function with display being passed to it. Well, what does display get? Display is a function that gets passed here. Then I go over here, I call this original function, namely display, and I execute it. So this message gets executed, and then I return that wrapper function. That wrapper function gets returned, and when I execute the function, the wrapper function, I get the results that you can see. Now, this is probably not what you expected. You came here expecting this @decorator function, etc. So that being the case, first let's make a small change to this. This wrapper function, I'm going to have a print statement that says wrapper executed before, and I'll pass to it the original function, its name, using the dunder name method. So let's do this first, and I'm going to comment this out and just run the display function again, just so you see what it does. It just says display function ran. Instead of doing it this way, which we assign the results, I'm just going to take this @decorator function and attach it to the display function. Now if I do this, you can see that the wrapper function was in fact executed. This wrapper function, this was executed, and then the original function was returned and executed. So this the return wrapper function was returned and executed. So I can see that display function ran. And that's what a decorator is. That's all it does. So I put a note over here that having the @decorator function is the same as saying decorator display equals decorator function and passing the function to it. Obviously, this is a lot cleaner to write than this. What if we want to pass arguments? What if I want to pass some arguments here? So let's take a look at having the display info, a new function display info that takes a name and an age. So I can say display info bugs and 47, and it basically just writes display bugs 47. Very cool. I can add my decorator function to this display. There you go. And if I run it, I get an error message. What's going on here? It says the decorator function, wrapper function, takes 0 positional arguments, but 2 were given. It says, well, this decorator function that you created over here, this wrapper function, doesn't take any arguments, but here you're passing 2 arguments to it, namely name and age. So what I need to do is I need to modify my wrapper function. It's very easy to do. It's always done the same way. You just pass the positional arguments and then the key value pair arguments, the star args and double star or double asterisk key value or keyword arguments. The order is important. Args comes before KW args. The name is not. You can call this Mickey and call this Minnie, and it doesn't matter. But traditionally, that's what they are called. You also need to, in the return original function, you need to return these values as well. So that's the only change I need to make. I made some notes here for you guys so it's clear when reading it later. So now if I run the same decorator function, def display, without any arguments, it's going to and then do this one. If I run, let me insert a cell above, and if I were to run display, you can see that it worked fine with that. But now if I run display info, which gave us an error before, it now works fine because it can accept either no arguments, because these could be 1, 2, 3, 4, 10 arguments, or 0 arguments, and the same for this one, the key value arguments. Okay, so very cool. It is working. We can also use classes as decorators. Now this is something that you might come across, so I'm including it over here. Instead of having functions be used as decorators, we can have classes. So I'm going to create a class called decorator class. I can have it inherit from object, although this is not necessary, but this is what inheritance looks like when you're inheriting. You just put the whatever is inheriting from. We need our init method, the constructor, and I'm going to use the self keyword and pass to it the original function. I'm going to say myself that original function is equal to what was passed, original function, which is fine. Now, we need to have the call method. We need the call method. This is what's calling the wrapper, basically. We're going to pass to it our arguments as before. So just so we see that it is working, I have a little print statement, call method executed this before. And as before, we'll just call the original function. But notice you have to say self.original function here because we're inside a class, inside of an object, and then calling the dunder name method. And simply return the original function with those arguments, just like we did over here. We're returning the original function with those arguments. This is what we're going to be doing right here. So this is the class, and I'm going to simply decorate this display and the display info with a decorator class as opposed to decorator function. So if I do this and look at the display, you can see that it's working the same way, except it is now using the class as a decorator. And let's go and take a look at the Bugs Bunny one, display info, which we are decorating here. And you can see that it works the same exact way, but it is now using a class decorator as opposed to a function decorator. So with all that being said, let's take a look at a practical example of using these decorators. So let's create a decorator to keep track of logging here. So I have a function called mylogger, which takes an original function. We're going to import the logging library of Python. I'm going to call basic config method of logging. File name is going to be whatever file name that we want to pass here, which is going to be the name of the original function that's being passed with a .txt, and this is going to create that file for us. And as far as we're concerned, we just want to get informational stuff. We don't want warning or error messages. So we're going to say level is logging.info. And notice I have a wrapper function which takes the variable arguments, and it's going to write this to the file logging.info ran with the arguments here and args, the args being the placeholder here and the kw args right here, and we're just going to pass those along here. Return the original function with those variables as before, and then return the wrapper as part of the mylogger. That being the case, let's take mylogger and decorate display info, which simply prints stuff for us. So let's run this. Nothing seems to happen, but I have a note here, file named after the calling function display info is created. And in fact, it is created. I'm going to bring it into view for you guys so you can see that display info.txt was in fact created. And right now it's empty. But now, if I go and run display info and pass to it bugs and say 47, you can, if I bring this back up, you can see that it ran that information for us. It wrote this for us in here. So here, so it's kind of tiny, I apologize for that. But info root ran with args, bugs, and 47, and kw args of, it's an empty dictionary that it ran with. Now let's take a look at this one, in which case I'm adding something that isn't there. There is no ID equals 201. If I run this, just ignore the error and check the file again. Let's bring it up, and you can see that it ran that information, and my kw args are now ID and 201. So it ran that in there. The function wasn't designed, display info, to handle that, but that's okay. This still logs it for us as what's going on. So creating a decorator that takes an argument, first a regular decorator that I have right here. As you can see, there's this perfectly, as I've done before. So I have my wrapper function args, kw args, print, wrapper executed this before. As before, we have the original function name. Result is equal to original function, and with the positional and the keyword arguments here, and then I have a print statement executed after, and I have a little line break here and return the results. So this is execute this function and return its result is what this is within the wrapper, and then outside will return the wrapper itself. Let's take a look at this. So I have my decorator function attached to display info here. And if I run this, you can see that it says wrapper executed this before. Then I have the function itself, and then I have the message wrapper or executed after display info. You can see that display info function, which is a function that was decorated, which was passed, is shown up as the name, and this is the name of that function. Finally, I wanted to have, just so you see that this stuff can build on itself. So I put a little thing over here. Let's say we want a customizable prefix for all the print statements, for instance. And my customizable prefix is coffee time. So I'm creating a prefix decorator, which takes a prefix. Then I have an actual, decorator function, which we've seen before, original function. Then I can have the wrapper function inside. So I have the, as before, prefix. I'm going to print the prefix that is passed, and then the wrapper executed this, get my results, then print the prefix executed after, and return the executed function. Return the wrapper and return the decorator function right here for the prefix decorator. So that returns that one. If I execute this and then do add prefix decorator, you get an interesting result. If I run this, you can see that everything works. I have a decorator of a decorator, if you will. So I have this prefix, coffee time, and I have wrapper executed this before the display info, which is the function name that was passed. Then the function itself is executed, okay, which is what we get here. Execute this function, return this result, and then I have basically the coffee time prefix that is showing up executed after the display info, and apparently I misspelled the word executed here. Executed. And let's do this so it is correct for the video. And this is an overview, a quick overview of what decorators are. So they basically modify the behavior of the function that they're attached to, and then return the results of that modification. That's in a nutshell what a decorator does. In many instances, you just have to know what the decorator function, if it expects any parameters and what it does, and that's it. You don't have to really get into the nitty-gritty of how it's doing what it's doing. You just have to know how to use it. And we'll see some examples of that. There's plenty of these things that are in Python, these decorator functions. And we'll come across them in future videos. Well, I hope you enjoyed this video. If you're enjoying these, please share with loved ones and friends. Thanks as always, for being a great audience, and I'll see you in the next video.